So in this section we are going to deal with thermal analysis of the material of steel block that carries two water pipes with two different temperatures. So the actual steel model block that I got is the .dmid file. Now we are going to see how we can actually open the .dmid file. Go to the start menu and then click on FEM Pro, and then once after we can open it by click on the opening tab and then click open, and then make sure you select the .dmid file and then click open, and then you can see it here. I would like to just maximum mesh this one at the 100 percentage. I'm sorry, 100 percentage mesh. The more finer you go, the much better results you get. So if you are looking at much accurate results, it's better to go for 40% or 50% rather than the 100%, and then you can actually see the meshing time varies from machine to machine. So the machines with good configuration can do the mesh much faster speeds. Then once after you do the mesh, go for the units and then select the inches as the units, and then once after you allocate the units, you can go into the FEA editor. On the bottom left hand side corner you can see my cursor here. This one right here is the FEA editor, where we can jump from the FEA editor to SuperView, and then initially to the CAD solid model tool. Once after we go into the FEA editor, as I earlier told you that this is going to be the thermal analysis, we have to go to the analysis pull down menu and then type as thermal and then steady state heat transfer. Click on the steady state heat transfer. Okay, and then go to the analysis parameters. As I'm running the program on a machine with Windows 7, I have to change the memory allocation to 10%, which is in default at 50%. I can change the memory allocation here in the options section. This one in default is used to be 50, but I have already changed it for 10%. So make sure you change the memory allocation percentage to 10% if you guys are running the program on Windows 7. And then here in the multipliers, make sure the convention multiplier is 1 and rest of them are 0. The convention multiplier right here is 1 and then rest of them are 0, and then that's all we have to change in the analysis parameters. And then click apply and then OK, and then go for the thermal. Click on the thermal, and then that's the same thing. So we don't have to change anything. Click cancel here, and then make sure you apply the material before you apply the boundary conditions. In this case, the material for this one is steel ASTM A514. So just go ahead and click. If you want to look at the properties, just go ahead and make sure that the properties of your block are match with the material library of the Algar, because sometimes there might be changes. Then you can go ahead and edit the properties here. You can you can enter your own values, and then just go ahead and click view properties and make sure that these properties match with your properties, with the material properties that you have already considered. And then click OK, and then click OK. Okay, and then now it's time for us to do the surface load. In order to select the surface load, go ahead and select the select surfaces thing from the surface selection drop down menu. Select the smaller hole, just turn around and then hold the control key and then select the opposite end of the surface, and then click add surface loads, where the ambient temperature in our case is 180°F and the convention coefficient is 93,380. So click apply and then OK, and then similarly I have already applied for the bigger hole, where you can see the load constraints here. And in order to enclose the whole structure to screen, it's in simple words, fit to screen, this one is right here. Just click enclose so that you can actually see the whole structure on your screen. And then once this is done, go ahead and then click the perform analysis icon all the way in the analysis tab, and then you will be directly driven into the super view, where you can actually see the whole analyzed structure with the von Moise stresses and stuff. Again, the analysis time will vary from machine to machine, as we know that we have applied the smaller hole has a higher ambient temperature. You can clearly look that the red color is at the smaller hole, and then the minimum temperature, that's the 65°F ambient temperature, is at the end of the larger hole. And then in order to view the load constraints in super view, you have to click this small icon to load and constraint display, and then you can clearly see the loads inside the two holes, which are carrying two water pipes with different temperatures. And then you can even create the animation using the Algar inbuilt animator, and then just click on the create animation. And then I prefer to go with the second option because the frame rate is good, and then just click save. And then you can actually see the variations in the block. If the Algar will allow you to view the animation right away once after it's created. If you want to look at it right away, you can click S, but in this case, as I have already seen the animation before, I don't want to look at it. Just click no. And then once after this excuse me, once after this animation is created, we can directly go to the report section, where the professional report is already created in default by the Algar software itself, in order to reduce the time and make it look more professional and more regular. Like, it will be easy for all the design engineers or the analysis engineers to go through the Algar report. This is the report tab right here, and then the image that you see on the front page of the report is the position of the structure in the FEA editor. So if you really don't like the structure on the front page or on the cover page, you can actually go into the FEA editor and then just kind of make it, if you want to click make it real in or something like that, just go ahead into that, go back into the report, and then click on the refresh report right here. Okay, and then here we can see the changed structure on the cover page of the report. And then if you would like to add some kind of animation to your report, and then go ahead and right click on the HTML report wizard, and then give the project name, and then give the project description. Write down your name or the name of the person who have created this report in the department, and then just check everything here so that it will allow it will provide all the essential data and the professional data that are really useful in analyzing the structure. And then here in this case, you can actually add some screen captures or animations. So go ahead, and I already added an animation here, which I can include in the report. Okay, and then click next, and then finish. And now if we scroll down, we can actually see the whole temperatures and processor information, and load constraints, how the loads are applied, and what surface boundaries are mentioned for the analysis from the structure, and the number of nodal points and the number of elements and stuff. As I'm saying, as I was talking, like, it has all necessary information. And here we can see the animation here. So the animation here will give more information. And then I hope you guys have understood the thermal analysis of the steel black, and thank you very much.